All right, hi guys. So we're gonna pick up lesson 5 where we left off. So the last thing that we did was we talked about Mason and Sebastian last class. So we're going to pick up at 5.4. We're skipping 5.3. So in 5.4, 5.4 starts off by saying you've explored output values with integer and rational exponents for the exponential function f of x equals 2x, or 2 to the x power. What happens when x is a negative value? So when we're talking about negative values now, we're trying to see that we have to remember our rule about negative exponents. So don't forget that whenever we have a negative exponent, in order to make it positive, we have to take the reciprocal of it, right? So if I have a to the negative 1 power, that would become 1 over a, where a's exponent now becomes positive. Same thing where if I have a to the negative 2 power, that becomes 1 over a to the positive 2 power. And then it goes on. Okay, so that's just a quick little reminder. Okay, so now let's put that into use here. So we're going to continue using our f of x equals 2 to the x power equation, if you will. Now they're wanting me to put in these different values in for our exponent. Okay, so if I do that, this first one is going to become 2 to the negative 4 power. Then I'll have 2 to the negative 3 power, 2 to the negative 2, and 2 to the negative 1. Well, according to our rule over here, in order for my exponent to become positive, I have to do the reciprocal of it. Okay, so I'm going to go ahead and do that. That's going to become 1 over 2 to the positive 4. And then if you want to simplify that, like if you don't want to have a power in your denominator, then you can plug this into the calculator and find what 2 to the 4th power is. So if you want to, you can pause this video, go grab yourself a calculator. That way you're able to do the calculations and figure out what they are. Also, it's probably good practice for you to learn how to use the calculator anyways. All right. 2 to the 4th power, though, is 16. So this fraction becomes 1 over 16. Then I'm going to do the same thing here. So 2 to the negative 3rd will be written as 1 over 2 cubed. 2 cubed is 8. So this fraction becomes 1 over 8. Then I have 1 over 2 squared. 2 squared is 4. So 1 over 4. And then 1 over 2 to the 1st. 2 to the 1st is just 2. So this is a half. Okay, so it says consider the table of values you just completed. Why does f of x change as x approaches negative infinity? Or how does it change? So negative infinity is going to be where x values are going to be getting smaller, right? So negative infinity on a graph, for my visual people, if I'm looking at a graph, I know that on my x-axis, the further I go to the right, I'm getting closer to positive infinity, and the further I move to the left, I'm getting closer to negative infinity, right? So the table, or this number 2, is saying, well, what happens as x continues to get more negative, right, as it approaches negative infinity? If I'm looking at these values, right, I have a half, a 1/4, a 1/8, a 1/16. If I keep going more and more negative, what are you assuming is going to happen, right? What do we know about 1/16 compared to 1/2? Well, 1/16 is a lot smaller than 1/2. So as I continue to go to the left, I'm going to get smaller and smaller. These values are going to get closer and closer to 0. Okay, so let's write that down. Let's say the y values are getting smaller or closer to 0. Okay, so it says an exponential function has a horizontal asymptote. Well, what is that? A horizontal asymptote is a horizontal line that a function gets closer to but never intersects. So the way I like to think of a horizontal asymptote is kind of as like a fence, right? if you've ever been like on a farm or watch any farm movies, you know that they have these things called electrical fences. And they use electrical fences to help keep their animals inside the farm or from being able to like go out or past it or whatever, right? So a horizontal asymptote is kind of like that, where your graph or graphs, so all of these lines here, are kind of your animals, all right? So a horizontal asymptote is usually going to be right underneath the graph. And again, it acts as like a fence or a barrier that your graph cannot touch or cross. So this basically says that your graph is going to be all on this side of our coordinate plane, but it's never going to reach or come down here. Okay. So with exponential functions, your exponential function is always going to have this horizontal asymptote. It's always going to have this barrier that it's not going to be able to touch. Now, based on where your graph is, that horizontal asymptote is going to move. Okay, so let's explore that. So for number 3, it says label your function f of x equals 2 to the x power on the coordinate plane and identify the horizontal asymptote. So here on your graph, right, you have 3 different graphs here. We see that black solid one, the gray solid one, and then the black like dotted one, the dashed one. So one of those is going to be my 2 to the x power. We have this table up here and then the table previously too to help us. So I know that I need, right, when I'm reading this table, I want to look at these values here. These are going to be my x values, okay? And these down here are going to be my y values. So I need a graph that has those values. So I have 0 and 1. Well, all of them are at 0 and 1. Then I have -1 and a half. So let's see, here's my -1. Half is right here. So this one. So this solid black line is going to be, let's do it here. I'm going to write it super small. So this black line is f of x equals 2 to the x. Now remember, it wanted me also to identify the horizontal asymptote. I like doing my asymptotes in highlighter. It just makes sense to me. Now my horizontal asymptote is something that's going to be, remember, at the bottom of my graph. So if I see that my graph is coming this way, right, and it's getting super close to the x-axis, but it's not touching it, my x-axis is where my horizontal asymptote is then. Okay, so, ooh, that's big. Let's do this. So my horizontal asymptote is here. Okay, let's see. I'm just gonna put C graph. Okay, number 4. It says functions g of x equals 3 to the x power and h of x equals 4 to the x power are also shown on the coordinate plane. Okay, so 3 to the x and 4 to the x, those are on this graph as well. We have to figure out which one is which, I'm assuming. So it says identify each function and explain how you know.
Lockdown, locks, lights.
Okay, so we have to explain how we know what we have. Okay, so let's go ahead and talk about that. So if I am doing, I'm gonna make them 2 colors. Let's do 3 of x in pink, and we'll make it h of x in purple. If I had to create like a quick table of values, right? Let's plug in 0 and let's look at the negative values. So if I had to plug that in, I know that this would be 3 to the 0 power. Anything to the 0 power is always 1, right? So I should have a point at 0, 1. Then if I plug in, -1, that would be 1/3, right? Because we have to do the reciprocal of it. I don't like the way this looks. Let me do it with a thinner pencil. Okay, so then this would become 3 to the negative 2 power. That would become 1 over 3 squared. 3 squared is 9. So I need something that's 1 over 9. And then here, 3 to the negative 3 power is going to be 27. So 1 over 27. Okay, so let's find points on our graph. So I have 0, 1, which if I looked here, remember, all of them came through 0, 1. So that's not much help. So then the next one I want to look for is negative 1 and 1/3. So 1/3 is about 0.33. So if I'm looking at negative 1, I have this one or I have this one. So 0.5, 4, 3, 2. I don't know, it could be either one of them. Well, this is probably 0.25, right? Because it's half of 0.5. So I'm assuming this gray one here is 3 to the x power. Which means the bottom one will be 4 to the x. And then again, the reason we knew that was because of the table of values, right? So let's just put that. So we used a table of values to find points on our graph. Okay, so then it says determine the horizontal asymptote for the functions, compare these with the horizontal asymptote from 2 to the x. Well, if you're looking over here, right, all of my graphs all kind of flatten out at the same spot. So all of them have the same horizontal asymptote. So this one is my horizontal asymptote for 3 to the x. And then let's make another one purple. This is also my horizontal asymptote for my 4 to the x power. Okay, so they're all the same. I know this because, again, my graphs all kind of flatten out at the same section. Okay, so we can just put, they have the same. I use a capital HA to represent horizontal asymptote just because horizontal asymptote is a really long word. So it says compare how each of these 3 functions approaches its horizontal asymptote. What is the same and what is the difference? Well, all of them are getting closer to it, right? So let's see, all graphs approach the horizontal asymptote as their x values get more negative. What else do we notice? I see that's the 4 to the x power. This one approaches the horizontal asymptote a lot faster, right? 3 to the x kind of approaches it also pretty quickly. 2 to the x, not really, right? So 4 to the x is approaching it a lot faster. It's getting there. It's getting closer to the line a lot faster than the others. Let's say, no, h of x, isn't it? Yeah. So h of x equals 4 to the x approaches the horizontal asymptote a lot faster. Okay, identify the domain and range for each of the functions and what have you noticed. So if you remember, domain and range. So domain, and we'll just put a little note over here. Domain is going to be your x values, right? And so we are looking at our graph on the left and on the right hand side. And then your range is going to be looking at your y values. So I want to look at my graph from the bottom and to the top. Okay, so let's start with domain and let's look at the black graph, the black solid one, the 2 to the x power. Let's look at that one first. So when I'm looking at this graph, I see that my graph has arrows on the ends, right? So if I have these arrows, that tells me that my graph is going to continue to grow, which means if I'm looking at my x values and I'm looking on my sides, this one is going to grow very far to the left. And so because it's going really, really far to the left and it doesn't stop, it's going towards negative infinity. Okay. Now on the right hand side, over here, I see this one has an arrow, which means it's also going to keep growing, which means it's not going to stop moving to the right. Because it's going to continue going to the right, that one's approaching positive infinity. Okay, so over here, and I'm going to go back to my color coordinating. For f of x equaling 2 to the x, my domain is going to be negative infinity is less than x, which is less than infinity. Okay. Again, this is telling me that on the left-hand side, I'm going to be approaching negative infinity. And on the right-hand side, I'm going to be approaching positive infinity. Now, because we don't know what infinity is, like I don't know what actual number value it represents, I can't say that I'm equal to it, which is why my inequalities are just less than. Okay. Let's do domain for the other two graphs, just so we're already on the same topic. So now we're going to be looking at the 3 of x, which is this gray graph here. So for this gray graph, it's very similar to the black one that we had above it, right? I have an arrow going far left, which means, again, I'm going to negative infinity. I have an arrow going far right, which, again, means I'm going to positive infinity, okay? And since we're here, let's look at 4 of x, 4 to the x, sorry. 4 to the x is this black dashed one. This one, same thing, has an arrow. Over here has an arrow. So our domain is still negative infinity to positive infinity. Okay, so the domain and ranges are, or the domains at least, are going to be same for all of them. So g of x equals 3 to the x. Our domain is the same. And then for h of x equals 4 to the x, our domain is the same. Okay, so now let's look at range. For range is going to be talking about the y values. So now I want to know, well, how low to how high is your graph going to go? Well, our graph has a horizontal asymptote, so I'm not going to be able to go, really, really low, right? My graph is going to touch, or not touch, but it's going to get really close to that horizontal asymptote. But remember, it doesn't touch it and it doesn't go past it. So because my asymptotes for all of my graphs are at 0, that means my graphs here are going to be everything above 0. Okay. And because this arrows, all of them, go up, I know that they're all going to go all the way to positive infinity. Okay. So for the domain and ranges of all of these functions, we're going to say the range is 0 is less than y, which is less than infinity. And this again is telling me that the lowest I'm going to be able to go to is 0, but I can't touch it because I have an asymptote there. So my inequality is just less than. Now the highest I'm going to be able to go, well, we don't have a limit, so we're going all the way to infinity. Again, we cannot know what number infinity is, so I don't say that I'm equal to it. I'm just less than whatever infinity is. Okay, all of our graphs had the same sections, so the range is always going to be the same. So what do we notice? All of the domain and ranges are the same. Okay. For 5.5, we're going to cross that out. We're not going to do that right now. I do want you guys to get some practice up here. So up here on number 4, they want you to rewrite each expression in radical form. Remember, a radical means that it's talking about your square roots. Okay, and then they want you to simplify if possible. So I will do one of them for you really quickly. I also want you to do 5 here. 5 wants you to go from a radical expression into a rational exponent. Rational, this word right here, if you want to highlight it, let's do that actually. A rational exponent just means that you want an exponent with a fraction. Okay. I'm going to put fractional exponent. So that's all it's wanting you to do. It wants you to have a fractional exponent. So it wants you to have a power, right? Don't forget what a power is. A power means you need a base and an exponent. Just this time your exponents are going to be fractions. So I will do A for both of these with you. And then I want you to do B, C, and D. Once you're done doing B, C, and D, go check the notebook and Canvas and you'll see the answers there to make sure that you did it correctly. Okay. So if I'm looking at 4 first. So 4 here. Remember that we had this rule, and I'll rewrite the rule. Your fractional exponent rule said that if you have a base to a fractional exponent, you can take the denominator of the exponent and write it as the index, right? So if we write it as the index, this becomes the nth root of whatever my a to the n power is. So we're going to be doing that, all right? So I need to take this denominator and write it as the index of my radical. So this is going to become, remember, if I put a 2 out here, I don't have to actually put it. That 2 is just telling me I have a square root, but a square root is the same thing whether or not I have that 2 there. And most commonly, you're not going to have the 2. So get used to not writing it. All right. So that becomes the square root of 4 cubed. Now it asked us to simplify if possible. So let's go ahead and simplify. Okay. If I have this, the way I'm going to simplify, and by all means, feel free, put this in the calculator, get used to the calculator and how it works. Okay. But remember, I can write this the same as doing the 4th root cubed, or not the 4th root, I'm sorry, the square root of 4 and then cubed. Well, we know that the square root of 4 is just 2. So this is basically telling me to do 2 times 2 times 2, and that becomes 8. So all that simplified is just 8. Okay, again, you're going to be doing B, C, and D the exact same way. Get used with the calculator. Know that the calculator cannot evaluate things with variables. So for C, you're not going to be able to get like a single digit number. It's going to have to stay with the radical. Okay. For B and D, try to simplify those as much as you can. If you get a decimal, you're more than welcome to put the decimal form there. But if you don't want the decimal, know that you can just keep it as a radical. When I do the answer key, I'm probably going to keep it as a radical just because that's usually how it's going to be on your test. Okay. 4, 5. Now they wanted us to go the opposite direction. So they want you to start with the radical and then go into a fractional exponent. So for that one, this is where you have the nth root of some a to the n power, right? And they tell you that you can take your index and write it as the denominator of the current exponent that you have. So this is going to be a to the m over n. Okay, so let's go ahead and do that. You're taking your index and writing it as your exponent. So this is going to be 2. This is going to be 2 to the 3/4 power. Okay, grab the calculator if you want to. You can plug that in, see what it gives you. I don't have a calculator here with me, so I'm just going to leave it 2 to the 3/4. Okay, but again, you're more than welcome to plug that in, see what it gives you. If it gives you a whole number, cool. If it doesn't, it's up to you if you want to use the decimal. But there you go. Check B, C, and D, and then the answers will be in the Canvas workbook. Okay. Let's see, what else do I want you to do? The worked example, you can look at that if you want to. It just has some more explanation. The other thing I wanted to look at is number 7 here. So this is just saying like how to simplify your radicals. I know that we did this already, so if you need more practice with simplifying radicals, do these for 7. Be honest with yourself on if you need the practice. I am going to just have the answer key on the Canvas notebook, so you can go back there and check it if you want to. Let me see, what else do I want you to do? I'm going to circle that. Okay. And the last thing I wanted to look at was 10. For 10, I do want all of you to do, okay? 10 here, what you're going to be doing is using all of the exponent laws that you have and trying to simplify these expressions as much as possible. I'm going to tell you right now, when it comes to Star loves asking these types of questions. So I do want you to attempt these. Let's do C. I'll do C with you really quickly, that way you know what to expect. But then I do want you to do A, B, and D. Okay, again, the answers for those will be in the Canvas notebook. So if I'm looking at C, I see that they have me multiplying 2 things. I have 2 exponents in both of them. They're the same exponents. So when I multiply them, we're going to be using the multiplication property. So I know that I'm going to start off with my coefficients and I'm going to actually multiply them. So 2 times 3 gives me 6. Okay. Now we're going to look at my x variables. When I look at my x's, because they both have the same base, my multiplication property tells me that I'm going to multiply or keep my bases basically the same, and then I'm going to add my exponents. So I have 1/2 plus 1/2, and we know that whenever we add them, they kind of keep the same base, and then the numerators are not the same base, the same denominator. The denominator stays the same and the numerators get added. So I have 1 plus 1. I'll do the work over here if anybody's confused. So I have x to the 1/2 plus 1/2. When I add fractions, you keep the denominator the same and actually add my numerator. So 1 plus 1 is 2. We know that anything divided by itself is just 1. So my answer is just x. So I become 6x. Okay. Let's look at the y's now. For the y's, I have y to the 1/3 plus just y. So this y here has an exponent of 1. Well, in order for me to add fractions, again, I need same denominators. So this is going to be 3/3, because I know that 3/3 is the same thing as 1, but it has a denominator of 3 in order for me to be able to add. So when I add these together, this gives me y. I'm adding my numerator, so 1 plus 3 is 4. My denominator stays the same, so that's 4/3. So my new expression is y to the 4/3. So tiny. Okay, now let's continue to use our exponent properties. And we know that if I have an exponent that is a fraction, we can rewrite that as a radical, right? That's what we've been getting a lot of our practice with. So let's rewrite it as a radical. We're going to take the denominator and write it as the index on my radical for that. So my final answer, I'm keeping the 6. I'm keeping the 6, keeping the x. Then my index becomes a 3. And then underneath it, I have y to the 4th. And there's your answer. Okay, so again, I just used all the properties that we've been studying. Remember, you have a cheat sheet back in lesson 1 or 2, I think, of topic 1. I don't remember. You can go back to your notes. You have that cheat sheet of all of your products and all of your rules. So you have that to look back at, but you're just trying to simplify A, B, and D as much as possible. And then check your answer with the notebook on Canvas. And then that's it, y'all. We're not doing the talk. And then you have your homework. So your homework is going to be due on Tuesday. Try your best with it. I don't think that there's anything super difficult in here. You should be able to do as much of this as possible and all of it as possible, actually. But if you have questions, I will see you tomorrow in class, and then we can go over some of those questions. Okay? Have a good day.